the lifeblood of any standardization activity is participation.
Yep.
So if you are in a company, or if you personally have the interest, do get involved in creating these standards. These standards don't create themselves; that they're all created by committed individuals that believe in the power of an open standard to move the industry forward.
Hi, I'm Sophia Moshasha, Special Correspondent of the WebXR Summit Series. Today we have Neil Trevett, who's the VP of Developer Ecosystems at NVIDIA and President of the Khronos Group, where he created and chaired the OpenGL ES working group that defined the industry standard for 3D graphics on mobile devices. Welcome, Neil.
Hey, Sophia. Good to be here.
So, Neil, tell us about your extensive history in XR and your origin story and how you got involved in helping to guide the developer ecosystems and standards development.
Good question. So, well, I've been around a while, and from all my career, I've been in 3D graphics. And in the early days of GPUs, there weren't any standard APIs for developers to do 3D rendering. And so very early on, I was so upset by seeing developers having to rewrite their applications every time they went to a new piece of hardware that I just got attracted into trying to help the industry move forward faster, because I want to see what happens next, by helping to create these, what we call interoperability standards. And the granddaddy of all interoperability standards in 3D is OpenGL, which came from Silicon Graphics originally, and then they made it an open standard. And then we created lots of different versions. You mentioned OpenGL ES, which was the version of OpenGL that really enabled good graphics in mobile phones. And then we did WebGL, which is again in the same family tree as OpenGL. And that enabled 3D graphics rendering in a web browser. And that kept us busy for around 10, 15 years. But now we're beginning to develop the next generation of open standards, which include new generation GPU APIs for 3D rendering, including Vulkan. Vulkan is the new generation API that's cross-platform open standard. And sitting alongside the 3D rendering, we now have, of course, XR devices, either XR in your hand or XR wearing on your head, and lots of cool input devices, eye tracking, body tracking, all kinds of things being worked on. And so now we have open standards, not for just driving the output pixels through a GPU API like Vulkan, but we also now have APIs like OpenXR, which is an open interoperability standard for doing everything else to do with an XR application. So figuring out where the help your HMD is, what your inputs are doing, and an application developer will typically use those two APIs side by side: a 3D graphics API for actually generating scenes and objects, and an XR API for doing everything else to do with the XR devices. So it's been fun. And Khronos is a standards organization. We've been around 20 years now, and we are having a lot of fun making sure that the XR APIs and the 3D APIs work well together. Our primary mission is to work close to the hardware. So we're typically the last layer before you actually get down into silicon. We like to say our tagline is connecting software to silicon. So our APIs are low level, close to the chips or close to the HMD devices. So people building chips or building HMD devices would implement our APIs on their hardware, and that enables the whole software ecosystem above them.
Love it. And you guys created 3 of the most important standards used by WebXR, WebGL, OpenXR, and the GTLF file format. I'd love for you to take a deeper dive into the importance of these formats and take them one by one, starting with WebGL, which has been around for a long time and has evolved to WebGL 2.
Yes, that's right. So, and actually, two of the standards that you mentioned are indeed APIs. The third one, GTLF, is a file format, and so they are slightly different. But we'll get there. The WebGL is the first generation of 3D API that has been implemented in browsers, and it came around because through our work with OpenGL 3D for the first time became ubiquitously available on pretty much every computing platform, not just PCs and high-end supercomputers, but also on people's mobile phone. And working with the web browser vendors has been a really fascinating experience. And they're of course, they're a very select group. There's only a handful of web browser vendors. So you need to work with that tight-knit community to make sure that what you're developing is going to be meeting their business and commercial and technical and security needs. And the fundamental thing for the browser vendors is they can't put anything in the browser that isn't going to run everywhere. Because the whole point, of course, of the web is that it's everywhere. So we couldn't put 3D in the browser. There had been lots of early work, Vermal. Some of your audience might recognize a very early attempt to define 3D for the web, but maybe it was a little bit ahead of its time because you didn't have accelerated 3D everywhere. But with OpenGL on the desktop and then its smaller brother OpenGL on mobile, suddenly 3D was everywhere, and so it became a possibility to consider. Now the web can run 3D everywhere. Perhaps we should put it into the web stack. And so the browser vendors, working together with all of the GPU vendors inside the Khronos group, we defined this JavaScript binding, essentially, a way to drive the native C OpenGL API from JavaScript, and that is essentially WebGL in a nutshell. It's driving pixels into the canvas, which was already there in the browser. The canvas lets you draw any pixel, and so now we have a JavaScript call into a 3D API that generates any 3D you want into a canvas that the browser can display to the user. And the web browser vendors don't get enough credit. It's a tremendous amount of work to make sure that a relatively complex API, a 3D API is more complex than a 2D API. It needs a lot of testing, and there are a lot of different GPUs out there with different bugs in their drivers. We try not to have bugs, but bugs are a thing. And so the browser vendors have put an enormous amount of effort to creating testing frameworks and putting a lot of effort into testing to really make WebGL the most reliable and pervasively available 3D platform anywhere. And now pretty much any browser anywhere, including on your mobile phone, can run WebGL applications. We then developed WebGL 2 that began bringing more than just the baseline 3D. So WebGL 2 has pretty much desktop class graphics running in the browser. And the next generation, and there isn't going to be a WebGL 3. The next generation is called WebGPU, and that's been created by the W3C, not Khronos. But WebGPU is based on top of the Khronos APIs like Vulkan. And it's interesting in the 3D GPU API land. We have gone through this transition from the older style OpenGL like APIs to this new style of 3D rendering APIs like Vulkan, and there's also DirectX 12, and Apple has Metal. All three of these new generation APIs give the developers much more explicit access over the GPU hardware. So you get a lot more control, which the developers have come to really love, because it gives them the flexibility and the performance that they need. And the transition in the web land is the same. We've gone from the older style WebGL API, and we're moving towards, it's not shipping in production yet, but hopefully soon, the Web GPU API, which builds on top of these new generation of lower level APIs. So, and the W3C and Khronos, we love to work closely together. There are many standards organizations out there in the industry. We all do our own, have our own area of expertise and do our own standards, but it's important that they work together well, and particularly the W3C and Khronos. So Khronos tends to work at the native level, and the W3C would build the web stack on top of our native APIs. And that's what's happening with WebGPU and Vulkan. We've gone from the older style WebGL API, and we're moving towards, it's not shipping in production yet, but hopefully soon, the WebGPU API, which builds on top of these new generation of lower level APIs. So, and the W3C and Khronos, we love to work closely together. There are many standards organizations out there in the industry. We all do our own, have our own area of expertise and do our own standards, but it's important that they work together well, and particularly the W3C and Khronos. So Khronos tends to work at the native level, and the W3C would build the web stack on top of our native APIs. And that's what's happening with WebGPU and Vulkan.
So could you tell us a little bit more about your relationship with the W3C? Would you say that you guys are more connected into industry and kind of getting that feedback and providing that for the standards that you're working on, as well as the W3C, or kind of what are those specific roles there?
Yeah, so we have a good relationship with the W3C. We can always do more, and that's why I'm happy to be here, helping to build bridges into the WebXR community. But we're both similar organizations with similar goals in our own domains. So we're both standard defining organizations. That means we're open, which means anyone can join and participate in creating these standards, and the standards are made available to the industry royalty free. And we do create standards rather than open source projects. So our primary products are not an open source project, but a specification and conformance tests. And that enables multiple vendors to implement that standard. And that's important. So in hardware land, my day job is at NVIDIA. NVIDIA sells GPUs, so does AMD and Intel and many other companies. You don't want to have a single open source GPU. It's actually interesting, but you don't want that in general. And the W3 is the same. They're creating HTML5 is the most obvious example, and WebXR is another example. It's a specification at heart, so multiple browser vendors can go off and implement in their particular browser. Now, we both love open source too, but open source tends to be a tool we use to build the ecosystem rather than our primary deliverable into the industry. So we absolutely need our standards to work closely together with the WebXR standards. And having the two organizations tends to work out pretty well. Khronos is where all the hardware guys go. We have every GPU vendor in the world pretty much helping to define APIs like Vulkan. And then the W3C is where all of the web community, including the web browser vendors themselves, go to help build the web stack. And the skills that you need are very different. in those two domains. They may look kind of similar from the outside, and they build on top of each other. But you need the right people around the table if you're going to build standards that really meet the needs of the industry. So we're happy to divide the work, and we're also happy to have a good relationship, so we make sure they work together.
So tell me more about why standards are so important, specifically in order to scale with the ultimate goal of making this content more accessible for the developer community, the businesses, and consumers as well.
Yeah, standards are essential to any industry, and the metaverse is a real buzz term right now, but in the end, the metaverse is just building out more internet with more spatial awareness and more advanced user interfaces, and just more functionality and connectivity and parallelization. To make that vision come true, so many technologies coming together in one coherent platform, like many people had imagined the metaverse to be. We're going to need a whole new level of interoperability, and interoperability, at its essence, is just communication, right? All kinds of communications are established and defined by open standards. It's plugging your plug into an outlet on the wall. That's an open standard. Plugging your USB into your laptop, that's another hardware open standard. But there are hundreds and hundreds of standards in the software space as well as the hardware space. Some of the APIs we've talked about are good examples. It's just a way that you can enable someone to build a product, and it will interoperate easily and seamlessly with the whole ecosystem without having to do one-on-one engineering continually, which just becomes busy work and for no value to anybody in the ecosystem. You can tell when a standard is needed when the more companies benefit from the interoperability than they do trying to compete over having something unique that doesn't interoperate with other companies. And 3D graphics and XR in the web has definitely reached that tipping point.
Yeah, absolutely. I mean, it's also a key selling point, to businesses and enterprise that want to invest in this, in these solutions and in this capability. They want to know that it's going to stand, that's going to last the test of time, and that their investment, it isn't going to be run over by something new that's coming on the market, or is not going to work with, with new developments that come out. So I think it's important for businesses specifically to know that there are standards in the making that are being processed right now with a lot of software developers, big hardware developers as well, to make them comfortable with the fact that this is worth the long-term investment.
Yeah, that's right.
Yeah.
I mean, the whole field of standardization is just as Darwinian, though, as proprietary products. I mean, products come and go. Some are successful, some are not. It's the same as in standards as well. There are standards that don't meet the right need at the right time and don't get widely adopted. So if I'm a developer looking to make wise decisions into what platforms and what technologies should I invest in, you're not just looking for any old standard. You're looking for the standards that are widely adopted, because once they do kind of reach that tipping point and they become widely adopted throughout the industry, then the well-being and the longevity of that standard is no longer dependent on any one company. And that's, I think, an important, it's a thread of continuity, because again, companies come and go. Their commercial interests can shift on a quarter-to-quarter basis. Things are here and then they're gone. But as soon as you have a multi-company generated open standard, any individual company can lose interest or gain interest again. It doesn't matter, because there's enough industry momentum carrying a standard forward for the industry's own benefit. So it becomes a self-fulfilling platform that you can invest in with confidence.
Yeah, and businesses can look at, potential other businesses in their industry, other competitors potentially, and say, okay, like there are standards being used industry wide, and I know that XYZ company is developing to this platform, and I know that consumers are engaging with their content that is developed on these platforms, so I can easily develop to the same platform using these same standards and convert those users or those consumers to my content on my platform.
Exactly. Yes.
Yeah.
Exactly. But it is a really interesting dynamic between proprietary products and open standards. One of the golden rules that we have in standards land is don't do R&D by committee. Don't do that because a standard it's at the right time to do a standard when the problem is already solved. You know how to do a problem. You're not breaking new ground with technology no one's ever done before. A standards committee is not the right place to do that. Having proprietary products that are groundbreaking, trying out new stuff and succeeding or failing in a Darwinian way, that's the right way to create new technologies. But once a technology has become understood and you've reached a stage where everyone needs it, you want it to be pervasively available, to become part of the platform that you can use to build the industry up to the next level, that is the time to create a standard. And in the past, Khronos has made that mistake. We've tried to do R&D by committee, and we've proven it doesn't work very well. But we're older and wiser now, so yeah. But again, XR I think is a perfect area for standardization, because we had a whole range of innovative companies that tried first and second generation products, and they have all now APIs that were proprietary, but they were basically doing the same thing. And that's, this is the time that we can standardize. No one loses by standardizing the APIs, but everyone wins through standardization. As you say, you have more developers connecting to more hardware easier, and that's good for everyone.
So let's switch gears. Let's talk about OpenXR. It's a runtime that allows engines to build uniform experiences that run on multiple XR headsets and other devices. One thing people don't really understand is that Chromium Core uses OpenXR to run in 2D desktop and mobile browsers. Can you explain the relationship between OpenXR and WebXR?
Yes. So OpenXR is just what we were just talking about. So over the last few years, there have been multiple hardware vendors creating all kinds of awesome XR devices, and we should say, of course, maybe everyone knows, but by XR, what we mean at Khronos by XR is augmented reality and virtual reality. And they did the right thing, right? They innovated quickly with their new products. They created the runtimes that you needed to drive an HMD and the input devices, and everyone ended up with their own runtime, with their own APIs that the software developers had to use to drive the runtime. So an Oculus API is basically doing the same thing as a HTC runtime API, but they are different APIs, so the poor software developers have to report and rewrite their applications. So OpenXR is all of the HMD vendors in the industry coming together at Khronos and saying, let's define a common interoperability API that we can all implement on our hardware, and then we get access to more developers, and the developers can run on all of the hardware. And it's been a 5-year journey so far in OpenXR, but we've again reached, I think, a really critical tipping point where the adoption in the industry has reached critical mass. It's unstoppable now. We have all of the major HMD vendors shipping OpenXR on their hardware, and major vendors such as Oculus and Valve are saying, we're not going to do our proprietary APIs. We're not going to develop them anymore. I mean, they're not getting rid of them. Everything will continue to work. But for new developments, we're going to focus on OpenXR. So OpenXR is the future. And all of the key engines like Unity and Epic now have OpenXR backends. And it sits perfectly next to Vulkan. So the application developers are enabled with an XR API and a 3D API to get really high performance, low latency XR applications running across the industry. And we're now seeing native applications using OpenXR. Microsoft Flight Simulator just implemented virtual reality, and that's all on OpenXR. Blender, which is a 3D authoring tool that many folks will be familiar with. It's open source. They have now, you can go inside your 3D models as you're designing them, and that's all using OpenXR. Minecraft now is using OpenXR. An increasing number of games that are shipping virtual reality are using OpenXR. So it's cool to see.
Yeah, super exciting. So GLTF, the GL transmission format, is described as the MP4 format for 3D models. Tell us about how it was created to be optimized for the web and how it compares with other formats such as Apple's USD and other popular formats like FBX and OBJ.
Cool. Yes. Good question. So whilst we were busy designing the APIs that we've just been talking about, OpenGL and Vulkan and OpenXR, we come into contact with a lot of developers, and more of them, of course, are developing XR applications. And we discovered that as well as driving into the hardware, everyone was going crazy through not having a file format that they could use in their XR applications, particularly in the web, which is by definition, you have to download all of your 3D models over the internet in a web application. You're not like a game where you can have a DVD and install a gigabyte of 3D models from your DVD drive. You have to get everything down over the internet. So the WebGL and the browser community trying to do 3D and XR in the web, we're at the cold face of the pain of having to download older style asset formats. And so we looked around saying there's got to be a solution to this, but it turned out that there wasn't. And we were looking enviously at the other media types, which all had a compact, well-defined, easy to process format. So images have JPEG or PNG. Even my mum knows what a JPEG is, and she can view it on her phone. It's easy, right? Everyone can do that because it's ubiquitous. It's and video, MP4, and other formats. Suddenly you have YouTube, but 3D, there wasn't a format that was designed to be pervasive, compact, and yet beautiful. It's not dumbed down. Compact, real 3D that was designed to be easily sent across the web and easily unpacked and processed and displayed in an application. And because it was the web guys that were feeling the pain first, WebGL 1.0 was designed pretty much hand in hand with WebGL. And so you unpack a WebGL 3D model, you don't have to do anything to the mesh or the shaders. You just basically just load it straight into WebGL with no processing at all. So it became very not only easy to download, very easy to process, even on mobile phones. And so WebGL 1.0 became very widely adopted very quickly throughout the web community. And there's no other format that really do that. You have OBJs. I mean, that it's not really up to date. It's only mesh and textures. You don't have animations. You don't have nice materials or anything like that. FBX is not an open standard. It's from Autodesk, and even Autodesk will be the first to tell you, we needed an open standard, and they're supporting GLTF. USD is interesting, and USD I think is going to be a very successful open source project. isn't actually an open standard, but that's okay. It's kind of an open source thing, but it's open. But it's very different to GLTF, and the two complement each other. USD is an authoring interchange format. So if you're creating assets, and increasingly, over the web, you're cooperating with multiple engineers or artists, and you're all in virtual reality designing a product together, you're swapping a lot of design information along with the actual meshes and animations. And USD, it's from Pixar. That's what they use to design their movies. It is designed to enable that kind of collaborative design, and it's awesome at that. GLTF is terrible at that because GLTF has been designed for a completely different purpose. Get it onto my mom's phone as fast as possible, which is very different to what USD has been designed for. But that's great because the two are going to complement each other. USD for the authoring and GLTF for the publication. And we're working hard to make sure, again, the two really interoperate together. So GLTF 1.0 became so successful in the web that all the native application guys started saying, hey, we need that too. But not everyone has WebGL type shaders. And so GLTF 2.0 made itself more portable by defining portably defined, physically based rendered PBR materials. So you have nice transparency, and have nice volume rendering. It's not defined anymore in terms of WebGL shaders. It's mathematically defined, physically based rendered materials, and that means you can run it on any platform. It's not just WebGL anymore. It's on Direct3D and any API and platform you want. So GLTF 2 has been the version that's really taken off beyond even the web into basically everywhere where people need 3D models that are easy to process.
That's great. So you guys have created the 3D commerce specification that many companies have adopted, and there's a certain certification process that's involved with this. Please enlighten us on how 3D commerce is going to facilitate transactions in the immersive medium.
Yes, this is another really interesting development. So, and this one's about a 3-year journey, I guess, from memory. To 2 or 3 years ago, a whole bunch of retailers trying to use 3D in e-commerce were trying to figure out how to make things scale to industrial scale. I mean, the technology for putting a new chair using a mobile phone and augmented reality into your living room was done back in 2013 by IKEA. Now, the technology has been around for a long time. The problem that everyone's having is to make it ubiquitous. And of course, now how do you solve problems of interoperability and make things ubiquitous? Of course, open standards. And so we had a group of retailers come to Khronos because we were very active in 3D and OpenXR already as the natural place to figure out how we could use interoperability standards to help 3D in retail scale up. And so for the first period as the group came together, we understanding what the problems are. And it really does come down to interoperability. If you look at the whole 3D commerce industry, you have thousands of companies designing millions of products, literally millions of products every year that need to flow out to end users through dozens of different channels. And at each point through that very complex web of companies trying to work together, there was no standardization. So it's not too much of a surprise that things were very painful and not scaling very well. From the kind of the technically involved, saying I want to have a nice PBR definition for materials, so my velour couch looks realistic, which of course what everyone needs. to the mundane, but saying that no one had standardized when you ship a model down this pipeline, which way is up. So different companies were just packing models in any old orientation.
Mm-hmm.
And that really struck home to me at one SIGGRAPH when a poor guy who was trying to do a website using 3D for retail, he was almost pulling his hair out saying, every model I get, I have to unpack it by hand, figure out which orientation it's in, get it into the right orientation, scale it correctly. And I can't automate anything. So everything is manual. I think, God, that's such a simple problem to solve. But I can tell, obviously it's really painful if you don't solve it. So the 3D Commerce working group, which is another working group inside Khronos, working very closely with the GTLF working group, are addressing that kind of problems. So they have 3 tracks. First is they need more GTLF functionality, and particularly for these new kinds of materials that are used often in 3D commerce. So they've been helping us define new GTLF extensions. They're defining guidelines for which direction is up and how to create a model that will ship reliably across multiple different platforms, including what technologies you should use, what texture compressions you should use, what PBR materials that work well, what size of models work on different platforms. And right now they're working on an actual tool to help. You can load your GTLF model into the tool, and it will give you gauges saying, this is good in this way, not good in that way. Have you thought about this and whatever? So to try to help designers creating these assets to create reliable assets that can be used everywhere. And then the last track of the 3 that you mentioned is certifying viewers, because there's no point having a perfectly formed GTLF model that's been very carefully designed if the viewers all display it in a different way. That's not a good way to give an end user a reliable experience. Your green couch has to look green, else you're going to get returns, and that's not good. So we put a lot of effort into creating a certification program. It's very inexpensive, and all the models and the tools are available in open source. But bottom line is, anyone who's selling a viewer that's going to be used in the 3D commerce industry can choose to become certified. They download a bunch of GTLF models, they generate test images, and if they look correct, and we're right now finalizing what correct means, and that's an interesting discussion, because there will be some differences, but what is too much? So that's what we're finalizing right now. But if you fall within the bounds of looking correct, then you become certified, and that gives confidence to the end users, and it gives confidence to the other technology companies in the pipeline saying, well, I need a viewer. Is this one certified? Yes. Okay, now I can plug it in with more confidence that it's going to display things correctly.
Yeah, it's kind of what UL is doing on the hardware side, just general hardware that you see out there. And again, it's all about making enterprises and companies and and end users as well comfortable with making this investment and kind of knowing what they're going to get out of the box, and not having to recreate these standards and these files over and over again.
Yes, exactly. Yeah, confidence and availability, they're the 2 things that standards give you. Exactly.
Yeah, absolutely. So a little bit outside of graphics, but in XR, there isn't a lot of current infrastructure around e-commerce. What standards are being put in place to handle financial transactions in immersive environments? And are there any blockchain components or integration with distributed ledger technology?
Blockchain is not my area, so I'm not sure I can add much. I think the bigger question in metaverse land is absolutely economies and currencies, and having those interoperable between the various services and sites that are going to be on the metaverse, which would include, of course, sites that are being driven by AR and VR. It will be essential, and I suspect, like many others, blockchain will be an essential technology in that. But that's not an area that myself or Khronos is actively involved in, for better or for worse.
Yep.
Damn it! I should have done it and been rich by now.
I was gonna say, I'm sure we'll see more of that happening, and you guys are definitely set up to be, a key stakeholder, at least influencer, in what that infrastructure is going to look like.
Yeah, it is interesting. It's going to be interesting to see whether that whole, firstly, currency and blockchain, and also related security, trademarks, copyrights, and I think that is going to come into GLTF land. I think that people are going to be able to want to watermark and secure their 3D assets and sell them in a meaningful way. So I say Khronos hasn't approached that yet, but maybe it's coming towards us faster than we think.
Oh, it is. So we quoted you saying it will take a constellation of standards to deliver on the promise of the metaverse. What did you mean by that? And tell us about what some of those necessary standards are to achieve that true interoperability of the metaverse.
So it's kind of what we've talked about. Of course, everyone is discussing what metaverse actually means, but I think everyone can agree it's a consolidation of all kinds of technologies working together in ways that they haven't worked before. And it's from kind of the blockchain-based stuff that we were just mentioning, all the way through to 3D graphics that we've been working with for many years. It's going to be different hardwares coming together. It's going to be different servers and clients coming together. It's going to be AI services online that are providing data and insights. All kinds of things are going to have to work together that have never worked together before. And all of those interoperability points are going to require open standards. I think, again, you talk to most people in the industry, Ready Player One is not the way the metaverse is going to happen. I hope anyway. One company controlling everything, that will be a terrible thing. A very anti-web thing, right? And I just don't see any one company being able to pull that off. Though some may try, and good luck to them. But I think the spirit of the metaverse, and in reality, the only way that the metaverse can become truly global is to base it on the foundation of open standards. So no one company has control over critical choke points anywhere in this global infrastructure that we're building. Therefore, open standards become essential. Every time anything is communicating, hardware or software, you need an open standard. So just like there's no one company that can possibly build all of that value for everybody, there's no one standards organization that can possibly build all of the standards that we need to create all of those, all that interoperability. So we need more. I think we need more standards organizations creating more standards to keep up with the demand. I was talking to some other folks in the standardization space, and we were saying, "Are you getting busier?" We said, "Yeah, I'm getting busier. You're getting busier. We're all getting busier." It's like there's a demand and a need for more cooperation and interoperability as the technologies are coming into place to build these larger systems. And so we need to have the right standard organizations across the industry, and we need to have the right liaisons between them, so we're cooperating, not treading on each other's toes and not going off in different directions. And each of those standards organizations is going to need to be keeping up to speed on building the standards that their particular area of expertise is demanding, and the pace is accelerating. We can see it happening right now. So you end up with a constellation of these different standards created by different organizations and doing different things, but all being part of a larger whole.
Yeah, absolutely. Well, we thank you so much for your expertise. I'm sure we've uncovered so much that this community has not known before. And there's so much importance in establishing the fact that there are open standards that are that are being worked on right now. Again, I go back to this confidence from a business perspective, because we are here for the WebXR Business Summit. So from an enterprise perspective, it's it gives them the confidence in investing for the short term, for the long term. It gives them the confidence in, in us as creators in the XR industry, that they're not just in this, this niche industry that's kind of like working its way up. No, like the W3C is working on standards. The Khronos group is working on standards because it is needed. There's that many projects that are being created. There is a need. There is a vocal need from the enterprise community saying, we want to figure this out. So you're doing us all a great justice. We appreciate it.
You're not alone. And my passing thought, my ending thought would be, the lifeblood of any standardization activity is participation. Yep. So if you are in a company, or if you personally have the interest, do get involved in creating these standards. These standards don't create themselves; that they're all created by committed individuals that believe in the power of an open standard to move the industry forward. So, yeah, all these organizations are open to anyone to join. So, yeah, please join in and help us create the future. You'd be very welcome.
Yes, thank you, Neil.
Cool. Thank you.